Over 2 months ago, I made a video of what at the time I believe was close to a perfect sub 250 gram build. A 3.5 inch HD FPV quadcopter that was built from the best bench tested components, with what might have been an ideal thrust to weight ratio paired with overall efficiency. Where it failed was a critical design flaw in the frame impacting the durability, and a number of quality of life issues leading to constraints for things like the camera angle. I looked for an alternative, but couldn't find one that didn't have other compromises, such as weight. I decided that instead of adapting my component choice to fit an available frame, I could instead make a frame that perfectly fit my component choice and requirements. So that's what I've done. When designing it, I had a few core requirements. Properly fit my chosen components, have it more durable than the crux frame, even if it didn't have the noted flaw, not be heavier than the crux frame, with lighter being a bonus, no additional compromises, support both 14mm and 19mm cameras. Solving that last one wasn't logical with one frame, so I ended up making two. The Reaver for the 19mm Caddx Pro camera, and the Scythe for the 14mm Nano Pro camera. Let me dive into the logic behind the design of these frames and show you how they fly. I'm now at the point where I don't think I'm making sacrifices by flying sub 250 gram quadcopters, and that's a game changer for me.
Recursion Labs. For science.
I went through a number of design iterations, but I'm not going to bore you with all the details. I will say that originally I was considering an H design to keep the arms lighter and shorter, but I realized the design would be considered a compromise, so I rescinded. It's a good thing too, since I eventually swapped the base plate and tried it, and it flew noticeably worse, even with the correct motor mix settings. That leads to the first design choice, a true X design, with the center of a 20x20 flight controller mount being in the middle, with a perfect center of gravity. The frame only supports 20x20 flight controllers, with it being designed for the GHEMCU GHF 420 AAO flight controller in mind, but others should fit unless they are larger. The Caddx Vista stack goes on top to give me easy access to both the flight controller and the stack for maintenance. A full Vista stack will fit in the Reaver, but the Scythe is more compact and will only fit a naked Vista. There are also considerations for support of the upcoming walk snail unit, which I'll speak to later. The bottom is a single piece 3mm base plate, where the motor mounts all extrude to protect the motors in the front and the sides. Since I only mount motors with 3 screws, I only made them with 3 screw holes, which allowed me to save a bit of carbon without reducing the durability, since there isn't the additional hole. I ran some simulations on the bottom plate to try and eliminate weak points, and I'm very happy with the durability to weight savings trade-offs of the base plate design, which should hold up to a lot more than the crux base plate, even without the critical design flaw it had. I mount the battery on the bottom, but I wanted the option to be able to mount it on the top if I wanted to switch things up, so strap holds exist for both. I don't like frames that constrain the camera angles, so I wanted the ability to freely rotate the camera to any angle I wanted, while still being protected by the carbon without it being seen by the camera. And both frames allow camera angle all the way up to 90 degrees, with the Reaver allowing the camera to also angle down 90 degrees, if there was ever a reason to do so. The Reaver with steel screws comes at 23.7 grams, which is a little less than 1 gram heavier than the Crux 35, which is expected, since it needs to be larger for the 19mm camera. The Scythe weighs in at 21.55 grams, which is a little less than 1.5 grams less than the Crux 35, which I'm happy with given how much more durable it should be. I wanted to find a way to reduce the weight further without reducing durability, so I swapped the steel screws with titanium, further reducing the weight by a gram to 20.8 for the Scythe and 22.8 grams for the Reaver. I decided to replace most of the steel screws in the build in the same manner, with a few I'm still trying to source. In the past, people would make fun of me for using titanium, saying that saving a few grams isn't worth it, and to that I say, you can shoot me down, but I won't fall, because I am fully built. My Reaver comes in at a dry weight of 101.7 grams, just over 1 gram heavier than my previous Crux 35 build, but supporting a larger 19mm camera. The Scythe weighs in at 94.8 grams, more than 5 grams lighter than my previous Crux 35 build. This might not seem like a lot, but you can definitely feel 5 grams of additional or reduced weight on an aircraft this size. When adding a 4S 550 mAh battery, the all-up weight is only 156 grams. Only a few years ago I was struggling to get a 3-inch build below 250 grams, so this is really light, and it's a real game changer for sub 250 gram flight performance, especially since motors and propellers have improved. In the air, it doesn't disappoint. I was extremely happy with the performance of the last build, and changing the frame doesn't really change that much, outside of getting the thrust to weight ratio a bit higher on the Scythe, with or without titanium, which should give a slight boost of speed and agility. My goal here was for it not to fly worse, and I've exceeded that requirement. For just having fun flying around, I don't think I would rather fly anything else. I have a 5-inch HC race drive built that I've been working on making lighter, which has the same electronic electronics has this 3.5-inch build, but for flying around like a bird, I found myself always going to 3.5-inch builds. But what about for racing? I designed this race mohawk to make sure it was properly dressed for the occasion, and so it can flip in mode grass. This year is my first time racing since 2018, so better racers may have a different opinion, but flying my Scythe back to back with my 5-inch, I was getting better lap times on the Scythe, but the throttle was close enough that swapping between them wasn't terribly difficult either. It was just easier to make fast turns without having to counter as much momentum, and it had more than enough chooch where it was definitely not holding me back. I was also completing far more practice laps than in my 5-inch before having to come back to swap batteries, which was a nice bonus. The only real downside is that it has less of a chance of staying up in the air when getting hit by a 5-inch going at the opposite direction at full speed. What about cinematic freestyle? I wasn't so sure. I designed a mount for my naked GoPro to give it a shot, which wired into a connector I have at the back. I found it funny that the dry weight was 2 grams less than the original GoPro. Flying it the first time, I was surprised. I could definitely feel the additional weight, and I needed more throttle for the same moves, but you still had a ton of power to fly how I wanted. It felt like if I put a full-size GoPro on my 5-inch racer, if you can imagine that. Happy with the result, I took it out nearby to try to get a more cinematic shot. Cruising around, the quadcopter felt locked in, responsive, and smooth. I felt confident enough to free fly around this area to quickly grab this footage. With a 45-degree camera angle here, I still had plenty of throttle available to me, and it didn't feel like the weight of the GoPro was holding me back. When I was done, I was so happy with how the GoPro was working out, I started thinking about all the footage I could capture with something that was quiet and light that I previously wouldn't personally do with a much heavier and noisier 5-inch aircraft. I'm excited for the possibilities this opens up for me. What about for long range? Well, this I haven't fully figured out yet. I know I can easily get 7 to 10 minutes of fast cruising out of this, and I have a port available in the back for connecting a GPS on the top for optional peace of mind. So for medium range, I'm sure that this is fine. And I have a few ideas of some experiments I can do to see if I can extend that range a lot further. Truth is, I really have opportunities where I'd want to go out far, but that makes me more interested in seeing what I can do here, since having a dedicated long range build makes less sense for me. I designed these frames for me and what I wanted, and I had no intention of making these available for sale since I figured I might have unique requirements in how I build things. When I was testing these, I had a few people ask me if they'd be able to get one cut, and since I really don't want to manage logistics of doing so, CNC Drones here in Canada has offered to put it up on their store so that anyone can get one cut with the required frame hardware if you see this frame and component choice is something that you'd love to build. With the Walksnail HD system announced with larger mounting holes, I designed a top plate that would fit it based on the release specs that gives it a bit of a booty. It has 25 to 26.5 millimeter mounting holes and should fit anything with those mounts. This is only for the Scythe since the 14mm camera looks exactly like the Nebula Pro Nano and should fit perfectly. I'll leave links on how to get these frames in the video description, along with a link to Thingiverse so that you can print any of the TPU hardware you might want. If you end up getting one, please post pictures, as I can't think of anything more rewarding than seeing other people's builds or flights on it. More to come.